Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve these two problems using the concepts of dot product. So let's start with the first problem. How many vectors are perpendicular to vector A, which is equal to -1, 1? State the components of three such vectors. Now a vector is perpendicular to another vector if their dot product is equal to 0. So it's a very important concept you need to understand and memorize. So let's assume a vector that's perpendicular to vector A is x comma y. So we have to find all possible values for x and y. Now if this vector is perpendicular to vector A, their dot product should be equal to 0. So that's our first step. Now we can calculate the dot product by multiplying the x components and adding the product of y components. So the x components are x and -1. So we get, and the y components are y and 1. So x times -1 is minus x. So we can move the x to the right side of this equation, and that will make it equal to positive x. So we get y equals x. That means any vector in which the x component is equal to the y component will be perpendicular to the given vector A. Now there are infinite vectors possible in which the x component will be equal to the y component, like 1, 1, 2, 2, 3, 3, -2, -2. So that means the answer to the first part is infinite vectors are perpendicular to vector A. Now we have to state the components of three such vectors. So first possible vector can be 1, 1. So their x and y components should be the same. Another possible vector can be the -2, -2. And the third possible vector is 3, 3. So these are three possible vectors that are perpendicular to vector A. So we are done with the first problem. Now we can analyze the second problem. So as per the problem, give the components of a vector that is perpendicular to each of the following planes. So let's start with part A. XY plane. XY plane lies along the X and the Y axes. The Z axis is perpendicular to XY plane because Z axis is perpendicular to both X and Y axes. So any vector that lies on the z-axis will be perpendicular to xy plane, and a vector that lies on the z-axis will have x as and y components as 0. So one example of a vector that can lie on the z-axis is 0, 0, 1. So this can be the final answer for part A. Now we can analyze part B, xz plane. So xz plane lies along the x and z axis. The y axis is perpendicular to xz plane because y axis is perpendicular to both x and z axis. So any vector that lies on the y axis will be perpendicular to xz plane, and any vector that lies on the y axis will have the x and z components as 0. So one example of a vector that lies on the y-axis is 0, 1, 0. So this can be the final answer for part B. Now we can analyze part C, YZ plane. The YZ plane lies along the y and z axis. So x-axis is perpendicular to YZ plane because x-axis is perpendicular to both y and z axis. And any vector that lies on the x-axis will have y and z components equal to 0. So one possible vector that lies on the x-axis is 1, 0, 0. So this can be the final answer for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.